What is the change in entropy of mercury vapor when 0.5 kg of it condenses to a liquid at its boiling point of 357 degrees C? The specific latent heat of vaporization for mercury is 2.7 times 10 to the power 5 joule per kg. To calculate the entropy change, we use delta S equal to Q over T, where the Q is a heat transfer happens in the mercury, and the T is the temperature of the mercury. Please note that this formula, we can use it only when the temperature T is constant. Now in this case, since the process happened at the boiling point, which is a fixed temperature, so that means we can use this formula to find the delta S. Because the T is constant, we can use this. When the 0.5 kg of the mercury change from the vapor into the liquid, the heat it releases is equal to mLV, where the LV is the specific latent heat of vaporization. And M is the mass of the mercury. The temperature T is referred to the boiling point in this case. Now we add a negative sign here because this Q is a heat released by the mercury when it condenses from the vapor to the liquid. So that's why we add a negative sign here, and this indicates that the entropy change of the mercury also will take the negative value. So the entropy of the mercury will reduce in this process. We take the M as a 0.5 kg for the mass of the mercury, and the LV is a specific latent heat of vaporization given as 2.7 times 10 to the power 5 joule per kg, and the temperature in the equations is 257 degrees C, so we must convert it into Kelvin by adding this 257, we add it with 273.15. So temperature must be in Kelvin. The answer we obtain is negative 2.1 times 10 to the power of 2 joule per Kelvin. The unit of the entropy change is joule per Kelvin, as we can see from this formula, joule per Kelvin. The negative sign here indicates that the entropy of the mercury will reduce when it condenses from the vapor to the liquid.